All right, welcome back to factoring trinomials. This is probably one of the most important videos for you to watch. So it's very important that we are paying attention, taking lots of really good notes. If you need to watch it again, be sure you watch it again. Okay. So we're looking at a trinomial and we are going to factor it out into two binomials. Okay. And the way we typically do this, if x squared term does not have a coefficient, meaning you say the coefficient of 1, what we would do is we would break it up into two sets of parentheses where x is going to be the first term, because x times x is always going to be that x squared. Now keep in mind that what we have done before is we have gone from, say, x plus 2, x plus 3, and we have FOILed it out. We've multiplied it out. So we've gone like that, and then we've taken the 2 and multiplied this out to get a perfect square, or to get a square trinomial. Okay, so we FOILed in that direction. And then to go back, we're going to factor. Okay, so that's kind of where we are. All right, so now that we've kind of talked about that, we're going to go get into it. So we talked about two sets of parentheses where x is the first term because x times x is x squared, and we always need to be able to go back. Okay, now if you have both signs are positive, then that means to say both signs in my parentheses are also going to be positive. Okay, because positive times positive is a positive. We start getting into a little bit more complicated factoring when these are not positives. However, what is kind of nice is if you always look at the second sign, that's going to tell you if it's positive, that means that both signs in the parentheses are the same. If they're negative, then they're going to be different. Okay? Now, the first one is once you look at if it's positive and they're both the same, then you take a look at the second one, or the first one, sorry, and the first one tells you they're both going to be, in this case, positive. If this were negative, then they'd both be negative. Okay, so that's how we know that they're both positive. The next thing that we do is we take a look at the 12. Okay, so I need factors of 12, okay, that will then add up to give you 7. Okay, so if we take a look at what we have here, we have factors of 12. Well, 1 and 12. If I add 1 and 12 together, that's going to give me 13. 13 is not 7, so that's not going to work. Other factors of 12 are 2 and 6. Well, 2 plus 6 is 8, which is not 7, so it's not going to work. And then 3 times 4 gives me 12, and 3 plus 4 gives me 7. So therefore, 3 and 4 are going to be the factors that work. Okay? So that's what we plug into that second spot of both of those expressions. If we were to FOIL it out, okay, we would get what we started with, which is x squared plus 7x plus 12. Okay, so here are a few different, or a few how-tos, a few steps on how you could actually do this. I'm not going to go through the steps right now, but I will go through them as we go through examples. So my first set of examples here, I take a look. I look first at the coefficient of my squared term, of my u squared term. It's a 1, so I know that I'm going to have two sets of parentheses, and I'm going to have u as my first term in both of them. Next thing I look at is the second sign. okay, which is positive, which means to say I know that the signs in both of my parentheses are going to be the same, and they're both going to be positive. So positive and positive. Okay, then I take a look at the 24 and the 11. And I want two factors of 24. Okay, factors of 24 that add up to be 11. So for example, 2 times 12. Well, 2 times 12 is going to be 14, so that's not going to work. So for example, what about 6 and 4? 6 times 4 is 24. However, if we add them together, that's going to be 10, so that's not going to work. What about 8 times 3? Well, 8 times 3, if we add them together, is going to equal 11. So that means that 8 and 3 are what's going to go in the parentheses. Okay? Now again, I take a look at my first term, or at my y squared term, coefficient of 1. So I know I'm going to have two sets of parentheses. Both are going to be y, okay? And then I take a look at my second sign, which is positive, which means to say they're both going to be positive in the parentheses. Then, again, just like before, we take a look at the last term, we take a look at the coefficient of the middle term, and we're going to make our table. So I have two things that multiply to give me 17, but add to give me 60. Okay? So, okay, I'm sorry, and I actually put these in the wrong spots here. It's 60. We need things that multiply to give you 60, but add to give you 17. Okay, there we go. So, multiples of 60. So for example, 3 times 20. Well, that's going to be 23. That's not going to work. What about 6 times 10? Okay, that's going to give us 16. So we're close, but we're not there yet. What about 12 times 5? Well, if we do 12 times 5, that's 60. 12 plus 5 is indeed 17. So here is our answer. We're going to have plus 12, plus 5, and the order here doesn't matter. You're still going to end up to be the same. If I were to check this and we were to FOIL, y times y is y squared, y times 5 is 5y, 12 times y is 12y, and 12 times 5 is 60. I combine like terms, and oh my goodness, I got the same thing that what I needed to get. So we are in great shape. Now the next example is different. Okay, I have still my coefficient to be 1, so I do know that I am going to have my two sets of parentheses where my variable, and my first variable in both of them is indeed t. However, I take a look at my second term. They're both going to be the same. So I have the same signs for both of these. However, they're both going to be negative. Okay? Everything else works exactly the same. I look what multiplies to give you 28, but adds to give you 11. So multiply to give you 28, add to give us 11. So how about 7 times 4? Oh my goodness, I hit it off right away. So 7 and 4, which means, again, if I wanted to check 7 or t times t, t squared, t times negative 4 is negative 4t, negative 7 times t is negative 7t, negative 7 times negative 4 is a positive 28. Combine my like terms, t squared minus 11t plus 28, which is what I wanted. Okay, so you see how nicely that worked out for us. All right, next example here. This is also a different example. So take a look at the first term, coefficient of 1. So I'm going to have two sets of parentheses, both of which are going to start with z. Now, we take a look over here at the second sign. The second sign is negative, which means to say we're going to have different signs, which means one's going to be positive, one's going to be negative. Okay? Now, we still look at that positive because that positive tells us that the larger number or factor is going to be positive. If this were negative, then it would be negative. Okay, but everything else works exactly the same. So I take a look at my last term and the coefficient of the middle term. So the last term has to multiply to give us 5, and it needs to add to give us 4. And keep in mind that we're talking, and I should say negative 5. It needs to multiply to give us negative 5, and it needs to add to give us 4, which means since 5 is a prime, we're talking about 5 times 1. Okay? Those are our two factors. One of these needs to be negative. And since I know that my larger number has to be negative, then that 1 needs to be, 5 has to be positive, then the 1 needs to be negative. And 5 plus a negative 1 is indeed 4. So we know that that works. So the 1 goes with the negative sign, the 5 goes with the positive sign. And we can check to make sure that that works. Z times Z is Z squared. Z times negative 1 is negative Z. 5 times Z is 5Z, and 5 times negative 1 is negative 5. Combine like terms, Z squared plus 4Z minus 5, and that is exactly what we needed to get, so we know we did this correctly. So that is our factored form. Do have quite a few left. We're probably not going to do all of these, but I do want to do this next one. Okay, because it's kind of the same example as the one above, just because this is negative, so they're both different signs. However, we take a look over here and it's negative, which means to say the larger number, okay, meaning to say the larger factor is going to be negative. Okay, so again, I'm going to set up my two parentheses. We're going to have Z and Z. 1's plus, 1's minus. And same thing, we want to multiply to give us negative 5. This time add to give us negative 4. So 5 times 1. But this time, because we have a negative second term, that means to say the larger number has to be negative, which does indeed give us negative 4. So 5 goes there in this case, and the 1's going to go there in this case. And again, if we were to multiply this out, we would realize that we are correct. So again, same thing, just slightly different. Yes, it does matter. So please make sure you actually review the difference. I'm going to skip this next one. What I really want to get to is I want to get to something like this example, where notice you have two variables, okay? So, again, I'm going to start just like I did before. Coefficient of 1, x, and x. Notice I have a y squared, which means that my second term has to have a y in it, okay? Because I have an xy in both terms here, and keep in mind they're both going to be positive because the signs are the same. They're both positive signs. So now I need to find two things that multiply to give us 36, but add to give us 12. So 36 and 12. Okay. Now just for time's sake, I'm going to already tell you that it's going to be 6 times 6, which is 36, and 6 plus 6 is indeed 12. Okay, so that's going to be our winner here. So we're going to have 6 and 6 here. If we were to multiply this out, we would end up with this exact same thing. Another way we could write it is x plus 6y quantity squared. So just a couple different options. Either one of these would work, but just want to make sure we have that y in that second term as well for both of them. See you in the